guys. This is going to be the ProMax Glycol Dehydration Emissions Tool webinar. So this session is going to cover a pretty nifty template that we've put together recently. It's very useful for folks who are needing to estimate annual emissions for their glycol dehydration units. So we put together a very user-friendly Excel sheet that allows you to estimate emissions from multiple triethylene glycol units at once. So we're going to be reviewing that in just a few minutes, but just wanted to start by introducing myself. So for those of you that I haven't met before, and I see some familiar names in the participant list right now, my name is Zach Ormland. I've been with Bryan Research and Engineering for about, 6 years now, which is just crazy to think about. So my responsibilities at the company are for business support of our Eastern US and Eastern Canada territories. So my responsibilities include organizing and teaching these types of webinars and training classes, developing new business in my regions, making sure that current customers are getting the most out of their use of ProMax, and keeping them up to date on new features. So really, my job is to really help you do your job to the best of your ability. A little bit about our company. So to clear up the confusion, the name of our company is Bryan Research and Engineering. That is because we're located in Bryan, Texas, where Texas A&M is located. The name of our process simulation software is ProMax. So we've been in process simulation for well over 40 years. So we just want to make sure that you're aware that with every license of ProMax, you have access to our team of chemical engineers, and we encourage you to use us. It's included in your licensing fee. Let's just jump right in here. We're going to start by just doing a brief triethylene glycol unit overview, just to explain what the purpose of it is and how people use ProMax to model these units. So a triethylene glycol or TEG unit is there to remove water from hydrocarbon vapors. So the reason that we do this is we need to meet some kind of pipeline specification. Either this gas is lean enough to be delivered to homes and residential areas, commercial areas, or it needs to be further processed, and water needs to be removed to do this further processing. So we use a physical solvent called triethylene glycol to pick up the water that is entrained in this gas. So in the model here, that's what we have here, our dry basis gas. What we're doing here is we're saturating it with water to bring it to its water dew point, to represent how much water can be held in that gas. We're circulating at the top of this column, this glycol contactor, triethylene glycol, which will physically absorb the water and bring it into the liquid phase. And then our dry hydrocarbon vapors can then go on for further processing. At conditions that are best for the physical absorption of water by TEG, we want this to be at relatively low temperatures and high pressures, something to help keep it in that liquid phase. So we run these contactors at relatively high pressure and low temperature. Once the glycol comes out of the bottom of the contactor, we then have what we call a rich TEG. So this means it is now loaded with water. And to save money, we want to reuse this TEG as much as we can. So what we're going to do later in the process is reverse what we did in the contactor. So we operated at high pressure and low temperature to promote absorption of the water into the TEG liquid phase. Now we want to reduce pressure as close as we can to atmospheric pressure and raise the temperature, because we want to boil off that water that's loaded into that TEG phase. So to do so, we reduce the pressure at our rich flash tank. We also vaporize some hydrocarbons as well. We run it through a lean rich exchanger to increase its temperature, and then we boil off the water in our glycol regenerator. What we do is we have that temperature around 390 degrees Fahrenheit, as high as we can get without degrading the triethylene glycol. This does a good job to promote stripping of the water. So now we have our lean TEG. So now this is much lower water content for our solvent, and that gets circulated back. So we cool it and we pump it up to the high pressure that the contactor will operate at. And that's the cyclical process of this TEG unit. So one thing to note is, even though that's on the process side of things, What happens as a result of circulating TEG and picking up water is we also pick up some hydrocarbons. And as we pick up some of these hydrocarbons and then boil them off, we're going to have a problem associated with emissions. So that's what this tool is designated to do, is to track those emissions. So the main way people use ProMax to model these TEG units, they'll use it for design purposes. So they'll estimate how much TEG is needed for their system to meet a certain dry gas dew point. Typical specs that you see in industry, somewhere between 4 pounds per million standard cubic feet of gas, between 4 and 7. So that's the common spec that operators are trying to meet. People also use our tool to estimate what kind of boiler duty requirements they will need. They'll also use it from a troubleshooting perspective. Recently worked with a customer to help them troubleshoot their lean rich exchanger, which we learned was undersized, and that was putting too big of a burden on the reboiler. So these are some common ways that people currently use ProMax on the process side to help them at their plants. But the biggest reason people will use ProMax, especially that I've seen recently to model TEG units, is to properly estimate the annual emissions. So let's just go over where we will have emissions from this unit. So I mentioned before that as your TEG picks up water in the glycol contactor and pulls it into that liquid phase, we're also going to pick up some hydrocarbons. There are heavier hydrocarbons that specifically have an affinity for TEG. You might have heard of BTEX before. This is your benzene, toluene, ethylbenzene, and xylenes. They have a pretty strong affinity for staying in that glycol phase. And what happens is, as we reduce the pressure at our rich flash and lower the pressure even more in our regenerator and increase the temperature, we're going to drive off a lot of these hydrocarbons. And what we need to do is we need to estimate the levels of these hydrocarbons under steady state operation to make sure that we are properly permitted and that we're meeting, if we're doing annual emissions inventory calculations, that we're meeting our permit requirements. So the main spots that you'll see those hydrocarbons collect are in this flash gas of our rich flash tank, if one is present at your site, and the glycol regenerator, or you'll hear it called the glycol still, the overheads. So the main pollutants that we see from these units, it depends on what's in your feed gas, right? But very commonly we'll see the BTEX that I just mentioned, your benzene, toluene, ethylbenzene, and xylenes. We have our volatile organic compounds, or our VOCs. These are hydrocarbons that are basically propane and heavier, anything with 3 carbons and more. We also have our hazardous air pollutants, which are really important to track. One thing I wanted to highlight on the hazardous air pollutants is ProMax does a very, very good job of estimating methanol emissions. We know, especially up in Canada and in the north, as it gets to those colder months, you're probably going to be injecting a lot of methanol. Even in the south as well, it can get cold enough where methanol is required. And the reason methanol is used is to prevent hydrates or freezing to occur in your equipment. So methanol does a good job of deterring that, but it has a pretty strong affinity for being picked up by TEG units at certain conditions. So one thing that ProMax does very well is we have a property package strictly dedicated to handling methanol and its interactions with hydrocarbons and water. So this tool can very accurately track methanol in your system as well. Important note there is we have talked with some state agencies, and we've got good relationships with many of the state agencies who do these kinds of emissions reviews. And some of them have let me know that they are becoming a bit more strict on tracking methanol emissions at all sites, not even just dehy sites, but that's where it can be commonly found. Having a tool that can accurately estimate that is very, very important. Another thing that you'll see we summarize in our report are the greenhouse gases. So your carbon dioxide and methane, and we'll come up with what you hear a CO2 equivalent in our template. So the emissions tool was really created to help people who are less familiar with modeling TEG units in ProMax. So you could have done these kinds of reports on your own if you had the proficiency to use ProMax to model TEG units, but we wanted to create an Excel interface that automated this process. We want to have it be very user-friendly, something where you're just using a bunch of drop-down menus to change the configuration of your facilities and just type in values for the operating conditions. We also wanted something that was going to be able to create emission reports for multiple facilities at a time. That was feedback directly from you guys, our customers. In some of the other tools you use, you gave us feedback mentioning that it would be very beneficial to be able to estimate emissions from more than one facility at a time. So that's the beauty of this tool, is you're able to do that. So the question was, does the methanol calculation help in hydrate prevention as well? And the required amount or flow rate of methanol required for preventing hydrate formation in natural gas pipelines. So the answer is yes, we can do that calculation, and people do that very, very frequently in ProMax. What I'm going to do is I'm going to put together a poll question. Okay, so just got another question. In regards to benzene and hydrocarbon absorption, does the fluid package give different results when using TEG versus DEG? I've seen an empirical study that distinguished between the two of them. DEG absorbs less hydrocarbons than TEG. That's a good question. It should give different results based on our data fittings of the two different molecules with hydrocarbons. I personally don't have a lot of experience with DEG being used for these systems, though. So I'm not 100% sure what those differences would look like, but that does, what you're mentioning does make sense, that it would absorb less. That would be something we'd have to look at on an individual basis. Wanted to show you that ProMax is mentioned in subpart H. So this is the regulations that are used for estimating emissions for dehydration units. So this comes directly from the EPA. We are mentioned in this section of subpart H. This is the inspection and monitoring requirements. And if I do a little control F and type in ProMax, you'll see that we are written into the rule. So it says specifically that the owner or operator shall determine the actual average inlet waste gas flow rate using either these different tools. The way we've interpreted that rule is, well, if you are confident in our ability to estimate the inlet waste gas flow rate to a control device, so in this case, what we're referring to, if we go back to our unit, what they're referring to is vapors from our flash tank and our overhead regenerator that may be combined and go on to control devices. So a control device is there to reduce the ultimate hydrocarbon emissions that you're going to be venting. So this could be in the form of a combustion device like a flare. It could be a BTEX condenser, something that liquefies the hydrocarbons. Those kinds of control devices, we feel that if the EPA is comfortable with us estimating what that gas flow rate is and that gas composition is entering that kind of control device, well, if we're able to do that, that means that we are able to simulate properly the whole facility. You can't get a good, accurate estimate of your waste gas rate and composition without modeling the contactor well. You can't get a good idea of that if you don't model the regenerator well, the rich flash tank well. So we've interpreted that as we are an appropriate tool to be used under subpart H. I know for some background, the company that made Glycol actually wrote subpart H with the EPA. So that's why you see their name is written into the rule quite a bit. We are working with the EPA at the moment on a rewrite of subpart H. They have understood our concerns and what we pointed out to them, and they're looking to more clearly add ProMax into the rule. All right, here it is in all its glory, the Glycol Dehydration Emissions Tool. Guess what? You don't have to look at ProMax when you use this. The only part that you guys need to worry about is this embedded Excel sheet. So in ProMax, we have the ability to embed Excel sheets into a ProMax model. This Excel sheet is linked with the ProMax model. Using our scenario tool, which is used for case studies, we can automate multiple runs for different facilities. So what we've done here is we've coded up a template that utilizes the scenario tool to perform ProMax runs of multiple TEG units at once, and then reports them in a really convenient format that can be sent directly to your state agencies for further review. So I'm just going to review the Excel side of things. What we've done is we've embedded it so you have the ability to adjust some things in your ProMax model if you want, but this template was created with the intention of you not having to touch anything on the ProMax side. So someone asks, are we still concerned about emissions calculations if the vapors are going to a flare? The answer is yes. You still, even if you have a control device, from my understanding, and for those of you who get into this a little bit more, correct me if I'm wrong, but even if you do have a control device present, you still, in certain situations, have to report uncontrolled emissions. So let's say that flare were to not be operating properly or be taken down for maintenance, whatever it might be, you still have to report what the uncontrolled emissions would be. So that's what our tool will do. It'll break down if you do have a flare, it will show you what those controlled emissions are, and it will also show you what those uncontrolled emissions are as well. I believe for your permits as well, you'll have to do something called a potential to emit calculation, and that would be if that control device wasn't present. So it is still important to monitor what those emissions could be should those vapors not be going to some kind of control device. Great question though. So the first worksheet in our embedded Excel file, it's just going to be just a brief list of instructions for how to use it. We tried to make this as user-friendly as possible. So the first thing you'll do is you'll go to the dehydration scenario sheet. You'll input your process information, and then basically you hit run and you're good to go. It's going to automatically create reports for you. That's a good point. Cynthia mentioned that in addition, the flare controls up to 98%. So you have 2% of those are vented to the atmosphere. So even if you do have a flare present, it's not going to, or we can't assume that it's going to combust 100% of the hydrocarbons. So that's a good point. So this is the instruction sheet. We also have our template assumptions. So we wanted to be as transparent as possible with what we've done as far as assumptions in the ProMax model. So here's a list of all of the assumptions that went into this, with instructions on how to change some of these assumptions if you prefer to adjust them. Just some assumptions that are important to note. We use if you define that methanol is present in your system, we're going to first off switch to the Pang-Robinson polar package. This is where we have extra data fitting for methanol and its interactions with hydrocarbons and water. And we're also going to, as a conservative estimate, since it can be pretty difficult for air quality consultants and operators to kind of track how much methanol will be in the gas at the point of it entering a glycol contactor, we're going to assume that the gas entering the contactor is saturated with methanol. So this means that if you were to just increase the pressure a little bit or reduce the temperature a little bit, that's when methanol would drop out in the liquid phase. So we say this is the most methanol that can be held in the hydrocarbon vapor. So this provides a good conservative estimate for how much methanol is entering your system. Some other ones of note, we use a certain reaction set just to make sure, we use our Gibbs minimization technique for our flares, and this is just for accounting for how much CO2 is formed if we're sending vapors to flare. But I encourage you, once you get a hold of the tool, look through these assumptions, make sure that they are reasonable to you, and if you do want to change them, we can further review with you guys. All right, but you guys are probably most interested in our dehydration scenarios option. So this is the Excel sheet where you're going to actually be inputting all of the information for your facilities. That's a good question. So Steve asked, is the Peng-Robinson Polar package a customized package that BR&E has created from the standard Peng-Robinson package? Yes, so it is a customized package. It uses Peng-Robinson as a base, and then from my understanding, a lot of it has been data that we've collected from customers that have been willing to share their information with us, and we've input better fittings for how methanol interacts with hydrocarbons and water. But yes, it is a customized package. It's not something that comes just directly from literature. It's data fitted as well. All right. So the first step that we'll do is we will first enter in how many facilities that we want to report emissions for. To do so, you just click on this button at the top, and you can select a number up to 100. So you're going to have this dialog that pops up and tells you how many do you want to input. So let's say for now I want to input, I don't know, let's do 5 and hit enter or hit OK. It's going to add that many columns for you to input your different operating conditions. If you had less facilities and you want to remove some, you can go back to enter facilities and type in a new lower number. You can hit the clear button if you want to reduce it back to the bare minimum or 1. And the way we see most people use this and what makes it really useful is if you have TEG units that are very similar in operation and configuration and conditions, what we recommend first doing is input your conditions into your first facility column and then enter in new facilities. You'll notice once I did that, type in a number and hit OK, all of the values carry over. So I recommend fully configuring your first facility, then entering the total number that you want to add. So I'm just going to break down the inputs for you. As questions come up, just feel free to ask away. The first row is just going to be the facility number. We have our facility name. I'm just going with a mob movie theme today. So if you have any suggestions for our next runs, feel free to throw them in the chat. Your next option is your annual operating hours. So how many hours is your unit actually operating? So this is going to be a multiplier in the report side of things. So if your unit has only operated for half the year, even though ProMax is going to come up with a tons per year emissions value, we're going to make sure we account for how many hours the unit was actually in operation. One thing that we've done in this template is, and you'll have access to this if you have access to ProMax, we input little tags for each of these parameters. Just if you're familiar with ProMax and the what's this option, it's basically the what's this. We wanted to be as transparent as possible and help you, so if you wanted to try to figure it out on your own, that you'd be able to. So if you were unsure what some of these parameters mean, you can hover over them, and we have a good description of what that parameter is and how it corresponds to a ProMax input. So the first section is going to be your wet gas specifications. This is where we define our temperature, pressure, flow rate, and how much water is going to be held in that gas. So you have a few options for how to define how much water is in your gas. The default and the way that is recommended is to define that it's saturated. So this is saying that the gas is holding water up until the water dew point. So if we were to increase the pressure or decrease the temperature a little bit, water would form its own liquid phase and drop out. So this is the most water that can be held in the vapor phase. So this is the most conservative estimate for how much water is present. You can also use this drop-down menu to choose different options. And with this template, you'll notice we tried to follow ProMax convention. So for those of you who are familiar with inputting information into the project viewer, we follow the same convention. So anywhere where you see blue text with a white grid background, that can be overwritten by the user. Anywhere you see a gray grid background and the text turns black, that means it's going to be calculated or it's going to be not used as an input for that run. That's a good question. So someone asked, is this tool separately licensed or is it complementary for ProMax? As a whole, anytime someone has access to a license in ProMax, you get access to everything that is available in ProMax. And that's including these kinds of customized templates that we put together. We recently also put one together for reporting storage tank emissions. So storage tank emission reports, those are available to all of our customers as well. So it's complimentary as part of the entire program. There's no additional fee or anything like that. That's a good question. So you can choose between having it be fully saturated. You can choose a certain user input fraction of saturation, and that enables you to input now this fraction saturated option in Excel. If you put 100 here, that would be the same thing as saying that it's saturated. Or if you have some additional information about your gas, if you know its water content, you can select that option and directly input its water content in units of pounds per million standard cubic feet. So for this case, I'm just going to leave it as saturated. I'm going to leave the temperature, pressure, and flow rate. I'm going to zoom in a little bit. Hopefully that's a little bit easier to see. You can input the temperature, pressure, and flow rate as well. These are going to be direct inputs to the feed stream of the ProMax model. Someone asked, some facilities don't have a flash tank or the TEG just flashes in the regenerator. How do I eliminate that? You're going to be doing that here in this spreadsheet, and I'll show you how to. We're just going to get to that in a second. So once you're comfortable with your feed conditions, you can move on to the next section. And that's going to be where we're defining our lean glycol rate. So there's a few ways that you can define your lean glycol rate in this DHI emissions template. You can input a target circulation ratio. So this circulation ratio is a way to do it if you don't know the actual circulation rate of TEG in the system. Very frequently, people will use 3 gallons of glycol for every pound of water in your inlet gas. That is a good rule of thumb for how much glycol to circulate to properly remove water to meet pipeline spec. So you can choose a target circulation ratio and adjust that. What we recommend, and if it's known, this is the best option to choose, is to choose your actual circulation rate. So if you're doing annual emissions and you know the TEG unit circulation rate for each of these facilities, you'll directly input it in that field. Or if you want, and this calculation is just a little bit slower, but some people have requested it, you can force ProMax to create a solver where it will determine exactly how much TEG is needed to circulate in the system in order to achieve a certain target water content in your dry gas. So for example, if you wanted ProMax to estimate emissions based on the exact TEG flow rate needed to meet 7 pounds per million standard cubic feet on your dry gas, you would choose that option. The next option, and this is a little bit different from how our competitors do it, we give you the ability to input the number of absorber or contactor stages. The reason we do that is in testing, we found that it does play a difference in how much of the hydrocarbons are picked up. If you don't know how many stages or height of packing or number of trays are in your contactor, we recommend sticking with the default 3. But we've noticed that if you choose the target water content option for your lean glycol specs, making sure that your absorber stages are set properly is going to be very important, because the emissions will vary widely if you choose that target water content option. We have some rules of thumb for how many stages to choose based on the number of trays or based on the height of packing in that column. So that's where our version of what's this comes in handy. If you just hover over that parameter where you see that little red tag, it will tell you what the recommended option is. So the main rule of thumb here is anytime you have a certain number of trays, divide that number by 4. And whenever you have, for every 5 feet of packing, that will represent one stage for our template. All right, so the next option, and this is also where we differentiate from our competitors, this is where you'll choose how the reboiler operates. So this is very important in a TEG unit. It's very important to strip off as much water as you can. That way, when that's circulated back to the front end at the contactor, that you're actually picking up water with lean glycol. If you're not getting near 99 weight percent TEG, you're going to have trouble picking up water at the contactor. There are a couple ways you can do this. The way we recommend, and what should be easiest to come by based on operator information, is by defining the actual reboiler temperature. So I think in other tools, they limit you to just inputting what the lean glycol water content would be. With our tool, you're able to choose between the two. And we recommend choosing reboiler temperature whenever present. So I'm just going to adjust some of these as we go along here. All righty, so now we're getting to a previous question. Someone asked, well, what if my facility doesn't have a flash tank? Well, you can come here to the flash tank specifications and define that it is not present. So if it's not present, that will gray all these options out. You don't need to worry about it. If you do have a flash tank at your site, you'll input the operating temperature and pressure. This tells ProMax at what conditions to perform the flash calculation at. Okay, so there are also options for where to send your flash gas from your rich flash tank. If you don't have one, that's going to be grayed out. You don't have to worry about it. But there are a few places that you can send your flash gas. Since we need to limit emissions as much as we can either send it to some kind of combustion device. In this case, we call it to flare. We've seen some facilities, and this is a little bit more rare, where if there's enough flash gas there, they'll actually recycle it and compress it and re-enter it into the glycol contactor. Some people use it as stripping gas as well. And the final option will be if you vent it to the atmosphere. So you'll choose vent to atmosphere if there's no kind of control or recycling or stripping gas. That's a good question. So for the reboiler fuel for right now, what we recommend doing is choosing the to flare option. That's going to represent the combustion that gas will undergo. And that will make it so that the template is accurately accounting for the emissions. But that's a good question. So the stripping gas option, what that will do is that will route those vapors into the reboiler as additional gas to help strip off the water in the system. Let me get to the rest of these inputs. So there are other stripping gas options available. I personally have never seen this, but I've seen it in other tools, so we wanted to make sure we had it available. Some people, I guess, use nitrogen as stripping gas in their regeneration section. Some also use dry gas. So what they'll do is they'll take a slipstream of the dry dehydrated gas, and they'll use a small amount of it, route it to the reboiler, and that helps pick up more or vaporize more water at the reboiler. To toggle that on and off, you just simply use that drop-down menu and hit in use, and that gives you the ability to define how much is present. Same for the dry gas option. All right, so the next option is where are we routing our regenerator overheads? You can either route it to some kind of control device, or you can say it's vented, and later we'll define what those control devices are. So your glycol pump specifications. Some people use electric pumps, and some people use what you'll hear is Kimray pumps. Kimray pumps, what they do is they utilize some of that high pressure inlet wet gas and basically utilize its motive force to help pressurize the lean glycol going through the lean glycol pump. What that does and what that means for our purposes for estimating emissions is what we'll do is we'll take a slipstream of that wet gas feeding the contactor and route it to the rich flash tank. So that's where it could represent more emissions for you. So a gas injection pump or a Kimray pump that we're referring to here, you'll have the ability to input a pump volume ratio, and that's going to dictate how much gas is being routed, slipped past the contactor and routed to the rich flash tank, where it could contribute to more flash. Like we mentioned before, you have the methanol specification. Your two options here are just saying whether it's present or not present. In the future, we may have another input for letting you define an injection rate of methanol further upstream. We found that this is the easiest and best conservative estimate for now. By defining that it's present in the feed, like I mentioned before, it's just going to saturate your inlet gas with methanol. So the next option is basically if you have a BTEX condenser present. If you do, you'll just say that it is present, and that'll give you the ability to define the operating temperature of that BTEX condenser. We're going to assume that it also operates at atmospheric pressure, which is an option for input a little bit lower. Now, where do those BTEX emissions go after you run it through the BTEX condenser? Because there most likely will be some vaporization through that unit as well. Well, do those vapors end up going to flare, or do those get vented? So some facilities we've seen have a BTEX condenser, and then the vapors coming off of that BTEX condenser also go to a flare. Some are vented at that point, where it's low enough emissions that's okay. For this particular unit, I'm just going to leave that set to none. And then the final options are just choosing your atmospheric pressure, your control device combustion efficiency. Like we mentioned before, 98 is what's usually required by the states. And then the final option is your inputting your composition. So right now we have a very set list for you to choose from. We heard feedback from some customers wanting it to better match their lab analyses. We can adjust this list for you. You just let us know what works best for you. But we modeled this after FESCO's glycalc input section. So if you're familiar with getting lab analyses through FESCO, that's the component list that we use. That's one of the more common labs that we see used for predicting composition for gases anyway. You'll just type in the mole percentage. It doesn't have to sum to 100%. ProMax will automatically normalize the composition if it doesn't sum to 100%. But that's your composition input, and that's just for your inlet gas. And then the last options are for determining how your report is set up. So the first thing is, along with this ProMax file and this embedded Excel, accompanying it, you're going to get another Excel file. And this Excel file is the actual report template. So this is going to be what creates the links between the ProMax model and the specific results that you're looking to see and being able to send to the state. So what you'll do is I'll send you this ProMax file and this Excel report template. And what you'll do is you'll save that Excel report template somewhere on your computer. And then what you'll do is you'll make sure to reference that in this file path template saved in section. We have these find buttons. Essentially, it lets you browse your file explorer. So that'll let you browse your file explorer until you find where it's saved, and just ignore my very, very messy desktop. So this is where I saved my report. So I navigate onto my computer until I find it, hit open. I've already had it in there, but it will adjust based on that. So that's a very important part to make sure the reports are done properly. So the next option is, okay, so ProMax now knows where to go find the report template, but it wants to ask you, where do you want me to save the emission summary that I'm going to create? So that's what this folder path report save to option is. So you just need to choose a path on your computer or folder where you want to save it. So I see a lot of people just choose their desktop. Just in this case, I'm just going to choose the webinar folder. So these next options really depend on your personal preference. So this is just giving the report a name. Automatically, your report name will be based on your facility name at the top if you choose to create separate Excel reports for each facility. If you wanted, for example, to have all of your Excel reports in one Excel workbook instead, you'll set this bottom option where it says append all reports in one Excel workbook. You'll set that to yes. Then it prompts you to give the report name something different because it won't use the facility names for each one. So I'm going to leave that set to yes for now. I'm just going to call this webinar test. And we can adjust some of these parameters some more, or I can just show you what it looks like when we run it. So Mira asked if a TEG unit is part of several flow sheets of a gas plant treatment. So if you have a whole plant modeled in ProMax with your upstream facilities sending that gas to an amine unit and then to a TEG dehydration unit, could you use the Dehy tool to calculate TEG emissions? If you have a full facility model like that, it might be better to use that facility model individually without using this template, or taking your inputs from that unit and inputting it into our tool. Right now, this is really configured to be more of a standalone where it's not connected to other kinds of facilities. If you're doing kind of a one-off like that, if it's just one gas plant that you're looking to estimate TEG units from, or TEG emissions from, I recommend getting the information directly from that flow sheet. It'll be a bit quicker. Okay, so someone asked, when optimizing the reboiler, I am restricted by the max temperature the TEG can tolerate before it decomposes. Yes, that is the case. So I think it decomposes right around 400 Fahrenheit, if I'm not mistaken. And so the question is, will it be better to keep the reboiler temperature as the degree of freedom instead of the lean TEG water content? For ProMax stability and to better match operating conditions, yes, that is the recommendation, is to use the reboiler temperature. It can be there. You could come up with cases where you input a lean TEG water content where there's no, it causes ProMax to have difficulty solving because it's unable to achieve that lean TEG water content. So usually I see this for people who choose too high of water contents. It just really struggles to find that reboiler temperature that's able to do that. It will be much more accurate if you use what they're operating at, their reboiler at their plant anyway. So that is my recommendation, and I totally agree. That's kind of the basis for design for these anyway, is trying to get as hot as you can without degrading that TEG so that you can vaporize as much of the water as you can. Okay, so someone also mentioned that there's a rule of thumb for gas absorption and TEG from GPSA, and that's about 0.5 to 0.6 standard cubic feet per gallon of glycol. Okay, I'm unfamiliar with that specific rule of thumb. Is that for all hydrocarbons, or is that for BTEX? I know that GPSA specifically has something that the breakdown of what the BTEX pickup will be, but I wasn't sure if they had something for all hydrocarbons there. So another question was, does the tool saturate the natural gas automatically, or do I have to enter the specs of the natural gas by myself along with the expected amount of moisture? So the answer is, it's up to you. So with the different options for your wet gas specifications, you can either tell ProMax, hey, I want you to fully saturate this gas at these defined temperature, pressure, flow conditions. You saw at the bottom that you'll define the composition as well. So ProMax will automatically determine how much water is in there to fully saturate it. Or if you know how much water is present, you can choose that as well. That's exactly right, Bill. So Bill mentioned that the saturator has a solver depending on the parameters you enter. So Bill, you must be familiar with the tool a little bit. So that's exactly right. Based on these inputs that you're entering for determining how much water is in your wet gas, that's going to dictate how this solver operates, and it will force whatever water content you define or force it to be fully saturated with water. And then I think I got one more question here. So it says, this Excel will only work with ProMax, or will it work without ProMax? So this Excel template will only work with ProMax. So if your company does not have access to ProMax at the moment, you do need access to a license to be able to use this template, because what it does is it directly communicates with that embedded ProMax model to perform these calculations. All right, so we've configured our facilities. I'm not going to take up too much time adjusting some of the other facilities right now. I'll just leave it as it is, just to show you the solving and reporting process. So let's say we've configured all of our facilities. We are ready to run ProMax and create the reports. We'll hit Start ProMax here. So it's just giving you a warning saying, is all plant information entered? Answering yes will cause ProMax to solve. So I'm going to hit yes, and let's see what it looks like when it runs. So you'll see at the bottom of this Excel bar here, this is sort of our status bar. So this is where you'll see what part of the process it's in. So right now it's just transferring information from our scenarios to ProMax, and now it's actually running the scenarios. So if I switch over to the actual ProMax model, you'll see everything unsolved, and you should start seeing it turn green here in a second. Yep, so now it's fully transferred those parameters, and now it's running that first case. Once it's done solving, what it's going to do is it's going to create the report, and the report is going to look something like this. Here's one that I ran earlier today, just to show you what it looks like. Just pull it over on the screen here. So this is what a report looks like. So the report settings I chose is I ran the model with 3 facilities. I chose to put them all in the same Excel report. And this is just going to be an input summary and an emission summary. So at the top, it'll just tell you what your case name was, the ProMax file that was used. You'll input the date, then just like a quick description of some of the inputs. So how much, let me zoom in a little bit, how much dry gas ended up exiting your contactor, what was the water content. So this gives you a quick check to make sure that you met spec here, how much glycol was used, what was that glycol to inlet water ratio, and for how many hours in the year did it operate. So the first section is just an input summary. This is exactly what you saw on the dehydration scenarios worksheet, just the exact inputs that we've done. This is really important because this shows transparency to the states or the EPA reviewing these runs. They want to know how you set up the tool. This gives them the ability to do a quick spot check to make sure there's no unreasonable inputs here. And this gives them the ability to much more quickly do these kinds of reviews. So you have your feed stream specs, your lean glycol, how you determined what that rate was, reboiler temperature, and where the regenerator overheads were sent to, and so forth. So it's just a summary of all the inputs. Then we have the actual emissions reports. So this is going to be a component by component breakdown of your emissions. And we're going to break it down into different sections. There's going to be a section that reports the controlled emissions, and there's also going to be a section that reports the uncontrolled emissions. Both of them are going to calculate even if a control device is not present. If a control device is not present, though, you will see values of 0 for any of your controlled sections. If you do have a control device present, you will still see what the uncontrolled emissions would be. So we break it down into pounds per hour, pounds per day, and tons per year on a component by component basis. So you can get your BTEX options here, and then we summarize some of the more important ones. So your total VOCs, your total hazardous air pollutants, you can see methanol speciated there, in addition to your greenhouse gas emissions as well. And that's using the CO2 equivalent. We made sure to have the times 25 multiplier for the methane value. So here's the uncontrolled regenerator emissions, same kind of summary. We do the same thing for if a flash tank is present, the summary of what the controlled flash tank emissions would be. So if you route your flash gas to some kind of control device, or if it's vented, you'll see the breakdown in the controlled versus the uncontrolled section here. And then I think someone might have mentioned it, and I might have missed talking about it, but what if you wanted to see a combination of the two? Well, here's where you would see what the combined regenerator vapors and flash gas, rich flash tank vapors emission summary would be. So we're just summing those two values. That's probably the most important part of the report, is that emission summary and the breakdown between the controlled emissions and the uncontrolled emissions. Later on in the report, we actually have something called a equipment report or equipment breakdown. And that's just going to give you information about operating conditions of the different equipment and how much is vaporized at that piece of equipment or how much stays in the liquid phase. So in this case, we include all equipment even if it's not present. So in this case, we didn't operate a BTEX condenser for this run, but you can see here that we'll report 0 values for each of those. So here's information about the absorber. And this gives you a pretty good insight as to how much of your hydrocarbons are being pulled into the glycol phase. So this is a mass percent recovery of your hydrocarbons into each phase. So for the inlet gas entering your contactor, you're seeing the percentage that ends up in the glycol phase or in the gas phase. So this gives you a good breakdown. You can see just how much BTEX ends up in your rich TEG phase. One thing that was pretty eye-opening to me is how much methanol actually ends up in that liquid phase as well. This indicates that you really need to monitor it to make sure that you're not exceeding your HAP limits. We do the same thing for each equipment. So you have the same concept for your flash tank, seeing which components vaporize and which stay in your glycol phase. Same process for the regenerator. You'll notice that most of the hydrocarbons are about 100% here. So most of them are actually ending up in your overhead vapors. And then actual stream report. So you'll get to see your wet gas feed, flow rate, composition, and then what your dry gas as well. So that's the gist of the report. One thing that we find has been pretty useful to share with customers is I put together this dehydration report guide. So some of these parameters, if they're unfamiliar to you as well, what we've done is we've input red tags on each of these parameters. So that gives you a more detailed view of how ProMax is calculating this parameter. So we'll share that with you as well if you want access to that template. It gives you a kind of the what's this for this report. So I think that pretty much concludes what I wanted to talk about in showing you the report. Yeah, so overall, we wanted this webinar to just kind of highlight how people are currently using the tool, the capabilities of the tool, and really it's to make your lives easier, right? We want you to be able to estimate emissions from multiple sites at once with very little intervention on your part, besides for having to input these operating conditions. Obviously, there will be some cases where you want to do some additional customized things. We encourage you to talk to us about that. We'd be happy to help you adjust this tool to better meet your needs. So I saw one question was, what's the starting concentration of TEG? Oh, that's a really good question. So I think for the tool, we use about 99%. I don't want to interfere with that. But yeah, I believe we use about 99.98% for our starting concentration of TEG. We find that unless that it's much lower than that, it's not going to play too big of a factor on the unit. Really, what's going to better dictate your lean TEG concentration is going to be how you operate your reboiler. So if you have a good high reboiler temperature and you're making sure to strip out that water, that's how you're going to get the good high concentration of TEG. What is the optimum operating envelope, pressure and temperature for the feed gas? I'm not sure what you mean by that question. Are you talking about just what the optimal feed temperature and pressure are to better pick up water from the gas? As if that's the case, we want it to be. It's tough to say what the best option is. We err on the side of wanting to have as high a pressure as we can. That makes sense with our inlet gas. So typically these TEG units, from what I can tell, they almost always follow some kind of compressor station. So if you're able to compress your gas to over 1,000 PSIG, for example, you're at a pretty good range. And if you're able to cool your gas after compression to about 100 Fahrenheit, you're going to be okay. But we want to get to a relatively low temperature and a high pressure. I see these operate anywhere between, the most common range I usually see is between 800 and 1,200 PSIG. That doesn't say that you can't achieve your dry gas water content that you need at different conditions, but that's what I see pretty commonly. And then I also see temperatures really based on what you can get from your cooler in your compression train. So if you're able to get down to 80 Fahrenheit, anywhere between 80 and 110, you're probably in a good enough range, assuming that operation elsewhere in the facility is to the recommendations. All right, Allison, do you plan to add in a separate control efficiency option for the flash tank for if it is going to the reboiler and not the same flare as the regenerator? That's a good question. So, Allison, would that specifically have a different control efficiency? Would you prefer to have it set to like 95% in that case? Is that what's dictated by the state or EPA? Because we could add that. Use 50%. That's a good question. Yeah, we can make that available as well. Oh, okay. So that's a state by state basis then. Yeah, we can make sure to add that in as well. Right now, you'd have to do that on the reporting side, but we can add that in and make that an option. I'll jot that down. All right. Is it reasonable to consider that BTECs get completely combusted in the flare system? No, it is not. Not completely combusted. So, as mentioned before, these control devices will have a certain control efficiency. I think typically that it is set to 98%. So you can assume that 2% of your BTEX components entering your flare system are going to go unreacted. They're going to vent to the atmosphere. There could be some devices that are more truly closer to 100%, but for assumptions that the state and EPA are comfortable with, I think we choose 98% control efficiency. That pretty much concludes the presentation here, guys. I really appreciate your time. I hope you enjoyed it and feel like this tool will be really helpful to you, especially if you're in a role where you get into doing TEG unit emissions estimations. We found from feedback from you guys that this has been really helpful, especially when annual reporting season comes around, and that's what we like to hear. But if there's any ways to improve it, or if we can be helping you out in any way with this kind of model, please let us know. Feel free to call or email me. There's my contact info. That's what I'm doing on a daily basis is helping customers like you guys out. So I encourage you to reach out, especially if you want me to send you the template. Please just shoot me an email or give me a call after the session. I'd be happy to send it over to you.